Hello, everyone, and welcome to our Big Data and AI Toronto 2020 follow-up series. This is our second session. I'm Brandon Charbonneau. I'm the sales manager for Big Data and AI Toronto. I'm really happy to have everyone here today. We have a fantastic lineup of speakers for you. So I'm really looking forward to introducing both of them. Our first speaker is Rob Hedge. Is the Director of Developer Relations for MariaDB. And then our second speaker today, following Rob, is going to be Jane Moran, who is the Senior Vice President, Data and Technology at Air Miles. So both have some really fantastic material to present to all of you. So without further ado, I would I'm really happy to introduce our first speaker, Rob Hedgepath. Rob.
Yeah, thanks, Brandon, and hello, everyone. First things first, go ahead and share my screen here. I'm sure this shows up all right. But I'd like to thank everybody for attending, and I'd really like to give a big thanks to Big Data Toronto for allowing me to do this session. It's been an awesome experience so far, being able to present here, and I'm really looking forward to jumping into real-time analytics, or what I'm going to call operational analytics on tap. We're going to be discussing HTAP, which stands for Hybrid Transactional Analytical Processing. Quite the mouthful, but I'll dive into it piece by piece so that for those of you who haven't even heard of it, we'll have a pretty good understanding after this is done. Again, my name is Rob Hedgepath, and I am the Director of Developer Relations for MariaDB. And I want to first start by taking a look at modern applications, right? Setting the stage for what we see kind of in the industry now from an expectation standpoint, and the evolutions of our solutions and applications over time. And I'd like to do that by really starting with a very simple example. Now, a lot of times I do this because it kind of helps myself, right? To kind of start from the ground up and really start to build into what we want to be talking about today. But it's something I think that all of us can really relate to. And I put this sample application out here of kittyconnection.com, which I think is actually available as a URL. But pretend, if you will, that there is this application where you're wanting to store, much like a social media engine or, Facebook or something like that, but for your cat, right? And you want to store, maybe the name, the weight, other pieces of information, maybe some photos. And that information starts off right within your application. Say you built this a couple of years ago. You had a couple of users, and you're storing these things, this information for these cats, we'll say Slim here at 40 pounds, into a transactional data storage mechanism, right? Some kind of data storage solution that you're using to harness the power of Kitty Connection. Well, if Kitty Connection does what you'd expect it to do, right, and it becomes extremely popular, over time, you're storing some data, but then it becomes more and more popular and you're storing more and more information. So much information, right, that your transactional information over the course of time really becomes historical information, right? Things about your cats or Slim may change. So you've got lots of different data entries, different records for Slim, but also the data itself as it becomes, it increases more and more. So you have a higher volume of data that goes into your data storage mechanism, becomes more analytical, right? Where you can take previous or older data or, larger sets of data and be able to aggregate that or analyze that information to really add on to your Kitty Connection website, right? Where you may have to separate your information where maybe you've got some transactional data that, is most recent, right? Within the last year, within the last month, just depending how popular the site is or how popular the application is, but also depending on how much money you want to spend to store things is transactional data. And so you may decide, okay, I want to put that into some kind of analytical storage mechanism. And right now we're just kind of putting that up as this big black box of analytical data storage. Well, the benefit of this, right, that I think we all pretty much know, and we've seen within sites today, whether they be e-commerce or travel sites, any information that has, some analytical point of interest. We've seen that we can take all that historical or analytical information and really use that of value to maybe something like Kitty Connection, where we can start to incorporate things like machine learning or artificial intelligence on massive amounts of data that it's learned about over the course of maybe years or tens of years, and be able to provide feedback. So for instance, based on maybe the 4 billion entries that we have within Kitty Connection, we can see that your cat is in the 99th percentile for weight. So our recommendation, even though it may be more of a social engine for cats, is that maybe Slim should go on a diet. But this is only one particular avenue that an application that started very simple and with a particular purpose can take, right? Over time, applications can change in a multitude of ways. Either it be, by customer demand or responding to something like the pandemic that we've seen in the last year. Applications can change drastically. It may even be the case that maybe you want to come out with some kind of health division inside of kittyconnection.com and have some kind of IoT-based collar that judges activity. Well, you're going to be receiving a lot more information at that point, so it's likely that you're going to have to deal with analytical or historical information. And this presents a wide variety of challenges, whether it's, you've reached the analytical limits of a particular storage mechanism that you're using, right? Whether it's an actual physical limit of I can only store this much data, or really I can only afford to store this much data, you may have to make some hard decisions. It could be the case that, you may have to get rid of some information. So maybe you aren't able to keep all of the historical information within that, original transactional approach. And you have to start to think about, okay, is it worth buying, a data warehousing solution to be able to store this data into, and then be able to take advantage of that in my applications. And ultimately, this kind of drives into higher or increased expectations from your customer base, right? Or from the users of the application, where, if you give a mouse a cookie, they're going to want a glass of milk type analogy, where, maybe you have such a great product that your users just want more, and they see the capability or they see the potential that it could have. And of course you would as well. These are all the challenges that you're faced with when you're trying to maintain an application using the traditional transactional approaches, and then be able to incorporate things like operational or real-time analytics. But stepping aside really quick, because what I'm going to be talking about today is actually a MariaDB-based solution towards HTAP, or hybrid transactional analytical processing. But before that, we need a sidebar here for just a second and take a look at how MariaDB as a platform has evolved within the last decade, or a little bit over a decade, to create a truly complete database solution. Well, taking a look at kind of the overall architecture, very simple view of the architecture of MariaDB platform, we see a couple of pieces here. But for those of you that may not be aware, back in 2009, MariaDB forked, right, from this small company you may have heard of, which, or a small database solution you may have heard of, called MySQL. And over the course of time, from then to now, there's been quite a bit of divergence, and there's been quite a bit of product separation, right? And as it stands now, MariaDB platform consists of a couple of pieces. And quite simply, we can start really from the top here and looking at MaxScale. And in MaxScale, right, we can think of that as a database proxy, or really what we'd call the ultimate database proxy if we wanted to get a little bit marketing heavy on it. But it's a database proxy. It handles things, like query routing. It'll handle things like read-write splitting. It'll also handle things like automatic failover. So it handles a lot of the things that you'd expect to come with a database: security and preventing denial service attacks, things of that nature. But that's not really the focus of what we want to get into. So we'll dive a little bit deeper in that part where we see enterprise server. Now, MaxScale forms or creates this abstraction, right, for applications to actually hit MaxScale, and then it does all the magic that it does in order to get you into an enterprise server instance, or what we're seeing as an enterprise server instance. But there's also another option, right? There's also community server. So for those of you that may not be aware, MariaDB started in its roots deeply rooted in open source. And so we do have a community version of the server and an enterprise version of the server. And essentially, those are the same, but just like you'd expect in an enterprise product, you get some of the bells and whistles and add-ons that help things like security and auditing things that you would expect from an enterprise grade product. But whether you're choosing enterprise server or community server, ultimately underneath that, what we really want to focus on is this idea of pluggable storage engines. And we can see those by these little blocks, right? So we see InnoDB and column store and expand. Those are a couple of the pluggable storage engines that you can use within MariaDB server. And this is important because InnoDB you can think of as your traditional row-based read-write workload kind of workhorse engine of MariaDB, right? It's the de facto database engine that you would expect to whenever you write SQL against a relational database. Dipping a little bit below that, you can see column store. And the reason why it's spread across those big blue enterprise server boxes is because it is a distributed database, right? It's a distributed storage engine. And column store is actually a columnar-based database, which we'll definitely dive into today, as it's really the focus of what we'll be looking at. But essentially, a columnar database is different, right, than a row-based database, so a row-based storage engine, and the fact that it allows you to perform aggregate queries on columns in large amounts of information super quickly. Now, we're not going to dive into, from a solution perspective, how exactly that functions underneath the hood, but you can think of it essentially as organizing things rather than in table files. It organizes them into files of columns, right? So each column has a file or multiple files, and that's what allows it to do aggregations like averages and counts on, billions of records super quickly without indexes. And then below that, we have expand, which is another distributed system or distributed storage engine, but it's transactional based. Now, I'm not going to dive too much into it, but you can think of it as there's other options out there, like Cockroach, for instance, is a very similar example to that, distributed SQL. But this is important, right, as we move into HTAP, because MariaDB houses a lot or offers a lot of storage engines, right? Or a lot, I say several storage engines that you can use for a variety of workloads or a variety of use cases. Everything from InnoDB and MyRocks, where you're using replicated online transactional processing, to using more of a clustered environment like Galera. You can use sharding like you'd think of in like MongoDB type of sharding. You can use Spider. As I mentioned before, there's expand, which is distributed SQL. And then there is column store. Now, again, I'm going to point out column store because it is a distributed OLAP, so online analytical processing storage engine. And that's important, right? Because as we start to think about real-time analytics and kind of hearkening back to how we solved the problem within Kitty Connection, we have this idea of using a data warehouse, right? That's the traditional approach where you may have rows and transactions on the left-hand side here for Kitty Connection as it starts, but over time, you may want to input that information or archive that information into a data warehouse. And then periodically, hours, days, weeks, you may get information from your data scientists, the DBAs that sit on that data warehouse side, and be able to incorporate that into your application. But with HTAP and with the idea of pluggable storage engines, you can actually combine both row-based and columnar-based information into a single server instance. So as you see here on this left-hand side. And that's what allows you to do this hybrid approach, right? Hybrid transactional analytical processing. You're taking advantage of both row-based and column-based information inside of the same server instance. But of course, you don't have to sacrifice your data warehousing technique either, because certainly you could hook up applications like Tableau or Zeppelin or anything else that you might want to use specifically for reporting on that analytics side. Now, taking a look at this from a high-level approach, and very quickly, because I think I'm kind of running out of time here, is that if you think of a real-world scenario, right, and consider an e-commerce site where you may be creating orders. If we look at the top left here, we'll be writing in to the database using the max scale proxy. It's going to write synchronously to disk on the orders table, which is an InnoDB or that workhorse database engine I mentioned before. At the same time, we're going to asynchronously replicate into the column store database storage engine in a columnar format. And then we'll also replicate that information into any number of replicas or database server instances that may have replicas on them into the orders table. But what you don't see here is in replica 1 and replica n or any of the replicas, you don't see it it asynchronously replicating from orders into the orders history table. And that's because that is done through a distributed process, right? So as I mentioned before, column store is actually a distributed columnar database or distributed columnar storage engine. And so everything is really stored in a distributed manner. So there's one instance of that storage rather than exact copies within each of the replicas. And that's important because it allows us to take advantage of something called object storage. While traditionally row-based information is stored in something called block storage, which is super fast, but can also be really expensive. Object storage, you may have already heard of it, but things like Amazon S3, for instance, is much cheaper and is theoretically infinitely scalable, right? As you're able to add information into these objects. And that becomes much cheaper. And these are really just a few of the reasons why hybrid transactional analytical processing can be useful. And that was really just the gist of how it works from a workload perspective. Some of the things that I haven't even had time to get into are things like cross-engine querying. If you're putting two storage engines inside of the same server instance, you have the ability to use SQL on both of these two tables, for instance. So you can take advantage of transactional information that exists in a products table, or maybe you've got clickstream information inside of a clicks table that's a column store table. You can take advantage of that using cross-engine querying in a single SQL query. There's also a variety of different ways that you can import. If you think of Spark and Kafka, where you can load information into both NODB or the row-based and then the column-based information. You can use analytical tools like Power BI and Tableau through MaxScale with single queries. And there's a variety of different connectors that are available within MariaDB's ecosystem that allow you to hook into all of the different storage engines as well to help you take advantage of hybrid transactional analytical processing. I've rushed that kind of at the end, and originally I was really planning on being able to provide a live coding session, but I kind of bit off a little bit more than I could chew because 15 minutes goes by really quickly, especially if you're as verbose as I am. But one of the things that we've come out with recently is a new developer hub. And in this new developer hub, we aggregate a lot of this information, whether it be actual open source code samples within our open source GitHub account, to tutorials or walkthroughs, blog posts, webinars, videos such as this, which allow you to get in and take a deeper dive into HTAP. And one of the great things about it, as I mentioned before, is that community server is completely free and is something that you can go and you can either spin up on your machine bare metal, you can use a Docker container, or you can even get into our database as a service, SkySQL, to be able to take advantage of that. So if you have some time, I highly recommend going out, at least checking out mariadb.com/developers for a bunch of samples and content that may help you out. And with that, I would like to say thank you very much for having me, and I guess I'll hand it back over to Brandon.
Thanks, Rob. That was a great presentation. We do have a few questions. The first one in our Q&A is, where does it rank in Forrester or Gartner or other?
As far as, I guess, what rank? I'm sorry. The HTAP solution itself?
I'm assuming, yeah.
So I don't actually, so I stick a little bit closer onto the engineering side more than I do the marketing side, but that's something that I can certainly follow up on. I actually don't know the answer to that. I'm sorry.
That's okay. So we have one more question.
Sure.
So the second question here from our question Q&A is, what are the advantages of building an HTAP database compared with a traditional approach?
Yeah, so one of the things that is, and I kind of hinted on it before, is really that there's a couple of things. One, I would say time. So you save yourself amount of time where, rather than having to archive information into what would be the more traditional approach, right? So you're archiving data into your data warehouse. With an HTAP approach, you're actually asynchronously just replicating that information, but then it gets converted into a columnar format into your column store database. And this is particularly important from a time-saving perspective. Not only do you not have to wait for that archive data to be, recalculated or, structured in such a way that then it's, then it's sent back over into your transactional system and then maybe store it in a view or a table or something like that. The benefit here really is that because it's asynchronously stored in a storage engine that's on your server instance, you can write very resilient queries to be able to take advantage of that, right? So you could just be able to take advantage of, writing a single query to say, I want to join a NODB table like I had presented before to a columnar table, and then know that that data is going to be in there because the latency is around, nanoseconds to milliseconds as it moves that information from the transactional engine into the columnar engine, as opposed to having to wait for kind of that whole big, round robin stream of bringing that back from the data warehouse itself. And the other thing that I would say is that it also can be beneficial from a cost perspective, right? And maybe not in the way that you would think, where traditionally you're just matching up solutions and it may cost less for this one or that one. But you're going to have most likely different teams that manage different products, right? So different data warehouse solutions that may use, different types of methodologies for getting in and manipulating the data. You're just writing SQL against the HTAP in MariaDB, right? So you're just writing direct, SQL queries. And a lot of times that's a skill set that if you are already doing that from your transactional side, it's no problem to be able to do that from the analytical side as well.
Perfect. Rob, it's always a pleasure having you participating with us. We're looking for
thanks.
Future collaborations. We're going to be moving on to our next speaker. We have Jane Moran, who is our Senior Vice President of Data and Technology at Air Miles. And just a reminder to everybody, if you do have any questions for Jane, feel free to pop those into the Q&A box. Hi, Jane. If we could unmute. Yep, perfect.
There we go. All right, perfect. Thank you so much, Brandon. Really happy to be here. Are my slides showing up okay? Everything looks good?
Yep.
I'll take no answer as affirmative as well, and just sort of keep plowing through it. Really happy to be here today. I am a huge believer in data and the power of AI, and excited to be speaking on this topic. It's interesting because I started off as a data scientist, and just looking at how this space has evolved in the last 15 years or so. When I was starting, we would do data science by starting with a blank notebook page, and we'd just start writing the algorithm in whatever our programming language of choice was. And these days, the algorithms are oftentimes already designed and already part of a package of whatever your favorite language is to be dropped in. And the challenge has become the full deployment of these solutions. And it's really exciting for me to see them taking off at scale in the way that they are. And so what I'm going to talk to you all about today is not only the types of AI solutions that we're bringing into the business and how we're making sure that they're really driving business value, but some of the challenges above and beyond just the technical implementation, how to get the organization to really accept some of these solutions, how to make sure that you're seeing the value for all the effort that is being put into the data and AI space. So just to introduce the types of data sets that we're working with, I work for Air Miles, one of the most recognized loyalty programs in Canada. We have nearly 11 million collector accounts, representing 2/3 of the Canadian households. We're adding just shy of 1 million new collectors every year, 750,000, $600 million in rewards value, and cards are being swiped 1,000 times a minute, with rewards being redeemed every 2 seconds. I like to show this slide just to get a sense of the scale. Part of what we have, it's been both the blessing and the curse of working with a large loyalty program like this, is that, we get all this data. There's very rich transactional data that's associated with the activity that we're seeing Air Miles collectors engage in, whether they're shopping for groceries and swiping the card, or if it's LCBO, or if it's fuel purchases. There's a volume of data there that we're getting that is very, very rich, but it also means that as we're employing solutions that we want to launch into the program, we're always doing it at scale, and we're bringing it up to the million accounts 1,000 times a minute, often in real time, which is a real interesting technical challenge, but also super rewarding when we get it right. The primary way that we're using AI right now is in CRM personalization. So this is making sure that we're managing at almost an individual level what people want to do as their next best action to fuel their purchasing behavior, to make sure that campaign investments are getting good return on investment, and that there's engagement not only with the Air Miles loyalty program, but even more importantly, with the retailers that we're working with. So we're working with Sobeys and Metro as big grocery stores. We're working with Shell. We're working with Staples. We're working with LCBO. They're paying for their marketing execution. They want to make sure that their money is going in the best place. So what we've done is we've created systems of personalized offers. This is as simple as product recommendation engines. If we know that every time you go grocery shopping, you're going to buy chips, then we might want to give you a chips offer. If you're more established and you've been buying chips for a long time, you're engaged in those offers and we're trying to stretch you a little bit. Maybe we'll try to get you into something a little bit different. We'll add on, tortillas with salsa, for example, something like that. So it's the thank you for visiting, reinforcing loyalty, it's stretch opportunities, it's trying to get you out of the snack food category and recommending that maybe you're going to need toothpaste or antacids or whatever it is that goes along with those. All of those different types of campaigns being done at a personalized level to manage the ongoing relationship between a consumer and a retailer. But there's another type that we do as well, which is a stretch offer. Those are also being reinforced by AI in a different way. The stretch offers will say, for example, that if we see that you're normally spending $75 every time you're going grocery shopping, we might try to stretch you to $80. We might stretch you to $85 or maybe even $90. And the amount of stretch is going to be complemented by an award or a bonus offer. So it might be, a 5-mile incentive to get you to increase by $5 or a 20-mile incentive to get you to go up $10. That whole algorithm is being reinforced through reinforcement learning. How often is the campaign being responded to based on the amount of stretch and the associated incentive? And it's being tuned based on the behaviors that we're seeing at an individual level. What this is really bringing to life is that we're getting better campaign ROI in two different ways. First of all, we're able to target more precisely. We know which types of consumers are most likely to respond to each different type of campaign. And so we're reducing the email deployment or the app-based or the digital advertising or social, whatever channel we're using, we're reducing the cost to deploy because we're getting better at targeting those who are going to respond. We're also making sure that once they are responding, that we're not giving too little or too much, that we're balancing the need to generate increased sales, but to do it in a cost-effective way. Finally, less time and effort is huge. The more we can automate a lot of these kinds of decisions, the faster we can go. We can start to deploy millions of different campaigns or ongoing targeted offers at scale with less internal effort, which is important for the ongoing running of our business and those that we support. So lots of really good stuff in here, but it's not easy to do it. It's not easy to deploy. This is just an example of what this looks like when it comes to life. You're seeing here get 30 bonus miles coming up on your app. It's an app-based individualized deployment. These are the types of offers that are actually coming to life for our Air Miles collectors in the market. And we are seeing real results. This is important to remember that these solutions now are producing real results at scale. We're seeing marketing campaign ROI increase by up to 240%. This is a combination of better targeting and better knowledge of how to balance those offers so that we're generating the maximal return on them. And finally, we're seeing email open rates that are giving us good hope that what we're doing is targeting the right people. We're getting a 43% improvement in email open rates, which is meaning that we're delivering relevant messages and that we're maintaining positive momentum for our brands and the partner brands that we're working with. So that's what we're doing. I want to spend the rest of my time talking about the challenges of actually doing this. And the fact of the matter is that it's not all just technical. Certainly, there is a lot of technical infrastructure that is required to do this. We've migrated most of our database into the cloud. We're automating ETL processes. We are targeting the ETL process, the data management, the pre-processing, the deployment through the channels, and then reinforcement learning based on the results is all flowing together, which is a difficult technical challenge. But the more important challenge that we have been facing is how to really operationalize this at scale within the business. And the difficult challenge that we overcome is this chasm that often exists between our technical teams, our data science teams, and our IT teams, and the teams that are tasked with doing the actual business deployment and the operations. These are our account teams, our marketing teams, anyone who's actually providing the business service on the other end. And what we found as we've started to spin up some of these solutions is, first of all, lack of comfort with technical terms. The data scientists will go in and they'll want to talk about all the features of their algorithms, and it'll be over the heads of most of the users who are trying to actually go out and sell these things. Sometimes it's risk aversion within the business, that the business kind of understands that you can do this at scale, but are they really willing to put all their eggs in this basket? Maybe, maybe not. Sometimes in development, we're seeing difficulty in estimating timelines and costs. The newer the thing is that we're trying to do, the more difficult it is to estimate delivery timelines because you've never done it before. Same thing in building business requirements. Before you really know what it is that you want to do, how can you create detailed requirements? Finally, the last few, prioritizing your needs, managing multiple stakeholders, establishing change management are all some of the barriers that we've encountered. Not all with the same project, luckily. When things are going well, it's one of the things on this list is really the big barrier. When things are going badly, there's 4 or 5 of them happening simultaneously that we're trying to overcome. One of the most common conversations that I have with my IT teams or data science teams is that they say, look, I created a really good solution. I handed it off to the sales team or the marketing team. If they don't know what to do with it, then that's not my problem. And my constant talk track is, no, that actually is your problem. That means that you haven't created something that the business can take and run with and sell. And you have to take accountability for part of the delivery of the solution at the end of the day. It's not just creating something that is really technically elegant, that works really well, that drives the ROI. You also have to be able to communicate the value back to the business in order to deploy it. But there actually is, it's both sides of the bridge have to come together. It's not just one or the other. There's a whole element of communication that needs to happen in here. The first thing that I like to talk about is making sure that there's accountability on both sides for the inherent risk in development and change. Humans are bad at calculating risk. Sometimes businesses are very risk averse, even when they're wanting to lean forward. It's one thing to say, when it's someone else's money, yes, I want to lean forward, I want to put this on the table. But when it's actually your job, when you're the one who has to come back at the end of the day and say 3 months in, I have demonstrated that I'm generating more incremental revenue today than I was 3 months ago based on the fact that I adopted this solution. Sometimes you're not really seeing the revenue at risk until you adopt it at scale. And so you have to kind of invest before you see the return. One of the things that we've done is we've made sure that the technical teams actually have accountability for the results, just like their business counterparts, so that they can't just say, look, I've finished it, I'm throwing it over the fence, the accountability and the risk is no longer mine. I get to take on the development work, but none of the risk. Creating that kind of accountability starts to minimize some of this. There's always lopsided accountability. There's no way around it, but everyone has to have some skin in the game when it comes to this. Organizational change is one of the things that we have found to be a big barrier. Not only organizational change in terms of structure, we have changed our structure. We are moving more and more towards development pods, cross-functional groups where you have engineers and you have QA, but you also have your data scientists in there. You have some of the business accountability. You have UX and shared services who are contributing. How do we create those teams that are cross-functional teams dedicated to the delivery of a particular experience or a particular product, but still maintaining their lines of expertise so that you're not completely isolated with a pod of other people in your organization who are not data scientists, right? A single data scientist in a pod of engineers can start to lose the best practices and the knowledge of being surrounded by other data scientists. So it's moving to the matrix organization where you can get the best of both worlds. You're delivering according to a cross-functional team, but you're maintaining your standards and best practices in line with your area of expertise and your area of knowledge. Updating business processes is one of the last ones that I'm really going to touch on, because we're already running out of time. But many areas of the organization, and I feel like many organizations right now, are moving from a waterfall process that involves a lot of upfront planning to more and more agile delivery processes. And we have found that we keep swinging the pendulum. We get a little bit too waterfall where we're doing too much upfront planning, but then we get a little too agile where it's being interpreted as not needing to do any planning at all. I'll just do 2-week sprints and I'll figure it out as I go. That's a little too lack of planning. There is a happy medium where you know what you want to do. You're delivering ongoing feature upgrades in a 2-week delivery sprint framework, but you're also looking at the go-to-market strategy simultaneously. You've done enough planning and costing that you know when the timelines to deliver are expected, what the overall costs are, and what the benefit are, and that you're laser focused on that. One of the biggest things that we've seen is really trying to reinforce the need for a balance between, you can't be fully waterfall, but don't go too far down that agile pathway that you start to think that planning is not important. There is still a place for planning in agile processes. Do want to acknowledge that it is possible to get to the breakthrough. There are many challenges throughout this of building up, deploying, scaling, but where we are right now is at over 40,000 personalized offers a month. We are increasing customer engagement. We're increasing profitability and ROI through the at-scale deployment of these solutions. It absolutely is possible. The power of data and AI right now is more exciting than ever, better than ever. So, to all of you who are facing these, and I think most people are facing some or all of these challenges, keep going. Don't be discouraged. It is super exciting right now. And with that, I will turn it over to some questions. Thank you very much.
Jane, great presentation. We do have a few questions from the audience. So the first question we have is, was Smoky built in-house?
It was. Smoky was built in-house. Yes, it was built in-house, a combination of our data scientists and data engineers, and completely homegrown. Yes, we use some infrastructure. We're in AWS. We're on using Databricks to do a lot of our data management, but it's a custom solution.
Okay. And then we do have another question. Is Smoky an internal tool or something Air Miles is selling to other organizations?
We're using it within the Air Miles coalition. So it's being used through our coalition partners, who include the grocery stores, Sobeys and Metro. It includes Shell, it includes BMO, Staples, Lowe's Home Improvement, LCBO, for example. All of those partners within the Air Miles coalition have access to this tool as part of their ongoing CRM strategy, as part of how they execute the loyalty program through their banners. In addition, we're starting to look at Metro and Sobeys, for example, using their vendors, the P&Gs or the Johnson & Johnson. When you look at Staples, they're selling printers and they're selling computers. To what extent can those vendors who are selling products within the walls of our partnerships also use the solution to be doing better targeting based on knowledge of their consumers? We are not currently selling it outside the coalition, though. It could be, but it's not a decision that we've made at this time.
And we have one more question. How does Smoky navigate consumer privacy, especially with behavioral data?
Yeah, all of our marketing messaging is based on opt-in. And so one of the things that we do for our Air Miles coalition partners is that we manage all the opt-in preferences, the CASL compliance issues, all the regulatory issues that are going with it. We mask all the behavioral data. The behavioral data that we're using to target is separate from the PII information. So it's different databases. The machine learning models are based on anonymous consumer data data that have it's essentially aggregated transaction level information that is being transformed into the data science models. And it's only right at the very end, when it's going through the deployment, that the PII is put in a different situation for the purposes of marketing. And that's to enable the privacy as we're going through that. We're constantly looking at preference centers and privacy information. We think that more and more that's where the market is going in data, and making sure that we're being transparent about what we're doing and giving collectors options to opt out of different types of communications if they don't feel comfortable with that. It's an ongoing iterative phase that we're in.
Perfect. Well, Jane, thank you so much for joining us today, and I want to thank everybody that. Oh, we do have one more question. Are you using blockchain at Air Miles?
We're not using blockchain. Nope. No, we're using traditional points. We've been in the business since the early 90s, and so our systems for accounting for miles, managing miles balances on behalf of the collectors, billings associated with miles are also all done in a proprietary system that we developed. It's obviously gone through many iterations throughout the years, but have not adopted blockchain as the mechanism for accounting for loyalty points.
Perfect. Again, Jane, thank you for joining us today. Fantastic presentation. Thank you to everyone that joined us as well in the audience. As was posted earlier, we are going to have a replay of this webinar that will be available by Monday. And also, please join us for our next post-event webinar follow-up series, which will be happening on January 28th. Again, thank you to both of our speakers, and I'm looking forward to seeing everyone on the 28th for our session number 3.
Thank you, everyone.